Hey, Grayson.
Hello.
How are you today?
Good.
Good. I was going to start with, hang on, I'm sorry. I'm sorry, I was doing something on my other computer. So while I was loading this, I was going to start with, let me go back here. It's like the second page. Unless, like, I was going to start like in here, unless there's someplace else that you would like for me to start. Is there?
Me, probably so. I'm going to go and get my mask real quick.
Hey, Miss Sparks.
Hey, how are you?
I'm good. How are you?
Good. I was just telling Grayson that I was going to start with, page 2, since I feel like we've kind of gone over all 3 of my classes. I got through most of the first page of the review packet. So I was going to start with the second page, unless you've already been working and there's some that you're just kind of stuck on and you want to go to something else. I can skip around.
Yeah, that's what I did. I went through the whole packet and did like all the problems I know how to do myself and just left some that I don't know how to do. So it's just completely random, scattered everywhere.
Okay. All right. Well, like I think I've got through most of page 1 through all of the classes yesterday, but so I was going to skip all of those to make sure we're using the best amount of our time. So let's just look at page 2, everybody, and see if you have any questions on page 2. That's 9, 10, 11, 12, 13, 14, 15, and 16.
Can you do 14?
I can do 14. Was there any before that? I think I did. Didn't I do number 9? I think I did number 9 in all the classes yesterday, right?
Yes, ma'am.
Yeah.
I think so. You did it?
But then on the second page, I need help with 10, 12, and 13.
Okay. Well, let me do number 14 since she asked about that, and then I'll go back to those. Is that okay, Grayson?
Yeah.
Okay. Since you're skipping around anyway, it's cool. And that's good that you did that to build your confidence and fill out the ones that you know. I'm proud of the way you went about that. All right. So once again, like I talked about in class yesterday, don't skip any steps on this and just break it down individually. And kind of what I mean by that is, with the order of operations, you want to do parentheses or groupings, if you will, first. So what I'm seeing at the top, an exponent. So, that's just PEMDAS or GEMDAS, however you want to look at it. So as I'm looking at this problem, what I see to break down is I want to do the numerator first, because the numerator is a grouping, and within that grouping, I have parentheses and exponents. So that's the one that I want to address first. So what I'm going to do is I'm really not even going to mess with the denominator in my first step. Now, I mean, you could go ahead and combine it if you wanted to, just addressing the grouping on the top and the grouping at the bottom, but you don't have to. So what I would do is when you've got a power to a power, Remember, it becomes more powerful. So that means you're going to multiply, because multiplication. So when you're dealing with exponent rules, when you're multiplying something, you add the exponents. When you're dividing something, you subtract the exponents. And when you've got a power to a power, it becomes more powerful. Thereby, you multiply the exponents. So you've got -1 times 4. So at the top, now we have x to the -4th. And now we no longer have parentheses at the top. At the bottom, you could either rewrite it as this next step, or if you wanted to, if it's not too much for quote unquote skipping steps, you could, there's nothing to combine with coefficients, because the 2 is all by itself. Basically, there's an understood 1 over there, but 2 times 1 is 1. The x doesn't have anything to combine on that variable, but we do have y's to combine. And it's being multiplied. So when variables with exponents are being multiplied, you have the same base, you add the exponents. So -1 plus 4 is a +3. So now we have x to the -4th in the numerator and 2x squared y to the 3rd in the denominator. Okay, so there's nothing, the only thing that is alike left is your x variable. So when variables are being divided, that's what the fraction bar is. It's just a division problem. You subtract. Like bases, you subtract the exponents. So you have a -4 minus 2. -4 minus 2 equals a -6. So now we have nothing left in the top, and we've got a 2, an x to the 6th, because it loses its negative because you're putting it where it belongs. When it's a negative exponent, it belongs in the basement. Y to the 3rd. So D. Did that help, Reese?
Yes, ma'am.
All right. So just kind of breaking each one down is the best way to look at it. Was it confusing because maybe there was a 1 left on top? Is that what threw you off your game a little?
Maybe. I don't know. I think it was just hard at first.
Yeah. Sometimes when you subtract everything out and then that final answer has a 1 in the numerator or the denominator, that seems to throw a little, because you're like, okay, I just subtracted and added a bunch of positive and negative numbers. So now does that end in a 0 or a 1? But you have to remember, ultimately, we're kind of dealing with multiplication and division in these instances. But we're adding and subtracting the exponents only when you're dealing with a problem like that. But y'all are asking some good questions, because these are more of the difficult problems, the exponents, and remembering all of those rules. All right, number 12. So we have coefficients of 4 and 3. And basically those cannot be reduced any further. So I can pretty much tell you that's going to probably be in my end answer. So if you were a person that was just narrowing down your answers, you're probably going to end up with A, just because those coefficients aren't going to go anywhere.
But why wouldn't you subtract 4 minus 3?
Because you wouldn't do that on a regular Lord help me. I can't think of the word. What am I looking for? A fraction. Yes. I couldn't think of the word. Thanks for helping me out. That's just a regular fraction. Just like I was saying with number 14, you're not going to treat your numbers any different. The only reason we're treating the variables differently is because they have exponents to them. This is still a multiplication and division problem. Like this, is multiplication down here. This, basically when you have a fraction, that's really division. You're still dealing with a division problem. It's just we're giving you rules to handle the exponents on a division problem. So you're not really subtracting. This is still a regular fraction or division problem. That's still 4 divided by 3. The only thing that makes this any different is we're giving you a way to handle efficiently the exponents on variables. Does that make sense? Is that a better way to look at how you're differentiating them? The 4 divided by 3 is still the same. So you don't have any way that you're combining in. Good. I'm glad that helped. You don't have any way that you're combining y's. The y's still stay the same because there's nothing to combine. But now we have a -3 minus 2 on the x's. So that's going to be -5. It loses its
problem
negative.
is actually pretty easy.
Yeah, it loses its negative because you're putting it in its place. Once
Okay,
you,
I looked
all right.
at what?
Once you kind of differentiate that stuff, it kind of helps. Now on number 13, there's a lot going on, but what you want to do is just break it down. We don't want to do anything at the top. We're just going to leave it as is. Okay. And then we're going to deal with the bottom because there's a lot going on there. So what you want to do first is distribute that 3 to everything inside the parentheses. So, and when you have a power to a power, it gets more powerful. So you're multiplying the exponents. But 3 times 0 is 0. And anything, literally anything to the 0 power is 1. So that kind of rids us of our m altogether, because that would really be m to the 0 power, which is 1. So and that now we have n, 3 times 3 is 9. I guess I could write that if y'all wanted me to, if that helps, but it's still going to be 1. And now this is m to the -2 n cubed all over, and m to the 0 is 1, and 1 times 2 is 2. And then n, and this times sign tells me I'm going to combine my exponents, because this is the way to handle multiplying variables and numbers, things that have the same base and the ends are the same. So we'll add the exponents, and n plus a -3 is 6. And now we'll combine. This m to the -2. It's got a bad attitude, so it's going to go to the basement. And then 3 minus 6 gives me a -3. So it would stay in the basement. So my final answer is this, which is D.
Thank you.
Uh-huh.
If
Did you
anyone
get
else,
it? I'm sorry?
if anyone else doesn't have any problems they want to go over, number 10 is confusing for me.
Okay. All right. First, what you want to do is you want to distribute this 0 to everything inside the parentheses. And what is anything, literally anything to the 0 power?
1.
1. So if I distributed this 0 to everything inside the parentheses, literally everything inside this parentheses becomes a 1. Because 2 to the 0 power is 1. 0 times -1 is 0. And 3 times 0 is 0. So all of that literally becomes 1 times 1 times 1, which is what? 1. So all of that becomes 1. So if you ever see anything on the test with a 0 on the outside, literally it wouldn't make any difference. I could write z to the 12th. I'm not going to start with z because then that would not be an alphabetical order. I could have s to the -12, t to the 11th, u to the 22nd, v to the 80th, z to the 4th, all to the 0 power. And this whole thing would become 1.
Oh, so it's B, right?
Did you say B?
Yeah.
Well, this is 1. So now let's break down this piece right here. So you've got a 2, and then x to the -1 would put that there. So it's C. Because y to the 0 power is 1. Right?
Yeah. Okay, that makes sense. It takes me a minute to think about where you got that answer.
Okay.
Miss Sparks, can you do some on the next page, like 23, 24?
Absolutely. I sure can. All right. So 23 and 24, these are the difference of two squares if you were to FOIL, right? If we FOILed this whole thing out, remember FOIL? First, outside, inside, last. But if you look at this is a special factoring, or not a special factoring. If we were to factor the end answer, it would be a special factoring, which would be this answer right here. Remember going back and forth, the difference of two squares. When you have the same exact thing in the first and the second, then you know that middle term is going to cancel out. But let's FOIL it to prove it. But if you remember correctly, remember when we in the polynomial chapter, in the first section we multiplied, and then in the second section we factored, which is really the fancy word for dividing polynomials. But let's FOIL this first. That's going to be 4b squared outside minus 6b inside plus 6b last minus 9. So the -6b and the +6b cancel out, and you get that. But if you wanted a shortcut at the very beginning, when you have the same exact polynomial, see the first term and the second term, the 2b matches the 2b in the second set of parentheses. The 3 in the first set of parentheses matches the 3 in the second. What makes them different is the signs in the middle. So you know that that's going to be the difference of 2 squares. Recognizing that pattern. Great questions this morning. Good reminders. Now, when you have number 24, a lot of people want to just say, oh, I'm going to do this, but that's not the case, because this has to be written. Whenever you see this, make sure you write it out and FOIL. Write it out and FOIL. So first, 9r squared. Outside, 18r. Inside, 18r. Last, plus 36. Combine like terms, 9r squared plus 36r plus 36. Does that help kind of see the difference? And then
Yes,
25.
ma'am.
Okay, good. So this, once again, when you see this little squared on the outside, please make a note to yourself to write it out. 4 plus 6m times 4 plus 6m. So once again, you FOIL first, outside, inside, last. Combine like terms, which those are usually the middle. And that's going to give you C.
Miss Sparks, can you do 15 or 16?
Absolutely. I can do them both because they're a
After
little
that,
bit.
there's like only one problem. I'm confused on the front page. I tried it both ways and it doesn't make sense. It's number 5.
Okay. I thought I did that one in class yesterday. Let me look and see which one it was. And you eliminated the 9 Ys?
I tried, but it just, I don't know. I
If you
messed up
eliminate-
somewhere.
If you eliminate the 9 Ys, you should get negative x equals negative 7. And then x equals 7.
Don't you need to like add or subtract one of the 9 Ys and stick it on the right side of the equal sign?
No. With elimination, you just add the 2 equations together.
Oh, is that... I'm getting confused with substitution, right?
Yes. And then after you get the x, then you substitute it back in. So you
Oh,
try,
that's
if you
confusing.
don't need help on 15 and 16, you try that and see how that goes. And then I'll help you with it. Okay. Just try it. Yes.
Could you do number 10 as well?
I just did it.
Oh, okay. I just joined.
Oh, okay. All right. Yeah, I did it. And there's the answer right there. Because that second set of parentheses, you may want to go back because I did and watch the first part of the recorded math lab.
Yeah, that's
Because
what I'm
I
gonna do.
did. I was going to say I did do a good explanation that will help you on the test. I don't want you to miss that. But I
Okay.
know that we've got to try to cover a lot of ground today. So, and I'm not trying to be rude to anybody, but I want to try to get as many answers as I can possibly get answered in like an hour and a half, if possible. Okay, number 15. So what you want to do is you want to try to go, if at all possible, Reese, like in in order or get your like terms. And I will say CUDA is not always great about putting it in standard form, which kind of disappoints me, but their answers are all in standard form. So you want to combine like terms is basically all you're doing. But you first, if this right here was a subtraction, you would want to distribute that first. But since it is addition, none of the terms in this second set of parentheses, none of the terms, the signs will change since the middle operation is addition. None of the signs are going to change. So basically all we're going to be doing is combining like terms. So this is very different than multiplying variables with exponents, because now all we're doing is adding and subtracting variables with exponents. So now what's the most important thing is to make sure that the variable and the exponents match perfectly. So it is different than multiplying and dividing variables with exponents. So the only variable that we have with an exponent of 4 is in the second set of parentheses. So there's really nothing to combine there. So it would be all by itself. And it is the variable with the highest exponent. So it will lead the way. So we've got that one handled. There was nothing to combine it with. There is also only one variable with a third degree exponent. And that's right here. So there's nothing to combine with it. So it will stand all by itself. So that's handled. Now there are two terms with a second degree exponent. A negative 5x squared and a positive 6x squared. So remember, every sign has a number and every number or term has a sign. So that sign has to go with the number. All right. So we've got a negative 5x squared and a positive 6x squared. We matched the variable with its exponent. And so now we combine their coefficients. The coefficients are the number that precedes the terms. That's a negative 5 and a positive 6. So that's going to be a 1x squared or just an x squared because the 1 is understood. Now our final, we have a negative 4x and a positive 3x. We've matched the variable and its exponent, which is an understood 1. So now we'll take those coefficients, the negative 4 and the 3, the coefficient just meaning the number that precedes the variable, and we'll combine those. That's a negative 4 and a positive 3. So that's going to be minus 1x or minus x because the 1 is understood. So my final answer is C. Number 16. The very first thing I'm going to do on this, and what I hope that you all will do whenever you come to a polynomial where they're adding and subtracting, which is very different than multiplying, is go ahead. If the operation is subtraction, this is really like multiplying this whole thing by a negative. So it literally changes the sign on every term in that second set of parentheses. So my very first thing that I would recommend that you guys do is go ahead and do that. So I am going to then do negative 2k cubed. The negative changes the negative in front of the 5k squared to a positive 5k squared. And the negative changes the final term to a negative 4k. And now I'm going to combine all like terms. So I'm looking for a k cubed. There's a k cubed here and a k cubed here. So that's 4k cubed minus 2k cubed. So that's going to be 2k cubed. So I've got those handled. So I can mark those off my list. Now I'm looking for the k squared terms. I have a negative k squared here and a positive 5k squared here. So negative 1 plus 5k is going to give me a positive 4k squared. Now, my next one in line is just k all by itself. And the only one I have is this minus 4k. And now I have one constant. Those I handled, sorry. And that's an 8. So my final answer is 2k cubed plus 4k squared minus 4k plus 8. Any questions about those?
Can you do 17 and 18?
I absolutely can. Once again, the very first thing that I want to do is, because there's a minus here, please, 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 as y'all are doing this on the exam on Monday and Wednesday of next week, please, please, please take your time and watch your signs. So this has a minus sign in between two 3-term polynomials. So I want to make sure the very first thing I do before I start combining anything is distribute this negative to everything following the negative. So I'll just rewrite the first set of parentheses. And now I've got a minus 8n. That minus minus changes that to a plus 3n cubed. Once again, a minus minus plus 6n to the 4th. So now I've got that negative distributed, so I'm just going to combine like terms. The first one I'm looking for, the one with the highest degree, is the 4th degree term. So when I add those together, I've got 8n to the 4th. The next I'm looking at is my cubed terms, and that's going to be plus 10n cubed. And now the last that I have is a positive n and a negative 8n, which is going to give me a negative 7n for C. On number 18, it's a plus here. So I really don't have to distribute anything. I can just begin combining like terms. So I'm going to look for the highest degreed term, which is an r to the 4th. And I've got a negative 5r to the 4th and a positive 3r to the 4th, giving me a final answer of 2r to the 4th. The next term that I'm looking for, there's no thirds, so I'm going to look at the squareds, which is 8r squared, 5r squared, which is, and they're both positive, so I combine the coefficients, giving me a 13r squared. And then the final combination are my constants with a positive 7 and a negative 4, which gives me a positive 3. So my final answer is B. Any questions on 19, 20, 21, or 22? Anybody need me to do those? Those are all foils. Did everybody foil? I'm sorry?
I said no, ma'am.
Okay, everybody's good on those. Oh, everybody's good at foiling? I'm so happy. Just to confirm, to make sure you have the correct answers, it is A, is B, C, and D. Did everybody get those right?
Yes, ma'am.
Yay. Any questions?
Yes, ma'am.
Praise the Lord. I'm so proud of you guys. Let's see. We did 23, 24, and 25. 26, difference of squares. Answer is D. All right. Page 3. Once again, oh, wow. Those two are almost the same exact problem. 27, C. All right. How we doing on page 4? Any questions for page 4?
Number 28.
Okay. To factor it completely, two factors that multiply together to give you a positive 25 that when you combine them give you a negative 10. That's going to be negative 5, right? Negative 5 and negative 5, right? Does that make sense? Two factors that multiply together to give you a positive 25. If I multiplied negative 5 and negative 5, I would get a positive 25. But if I combine them, a negative 5 and a negative 5, I would get a negative 10. This is the answer, but can also be written like that. Just like I said up here, whenever you get to a problem, where was it? What was the one that we did together just a few minutes ago? Oh, yeah, number 24 and number 25. I told you guys to make sure you write those out when there's a squared there on the outside. When you're factoring, if you get two terms that are exactly alike, oftentimes they are written like that. Does that make sense? Because basically, to remember, a squared term is when you multiply a term by a term, even if it's a little binomial. Does that make sense to everybody?
Yes, ma'am.
Okay, cool. All right. Number 29 is the difference of two squares. 25m squared. What is the square root of 25m squared? The square root of 25m squared.
5.
Anybody?
5M.
5m. So in the square root of 9 is 3. So the difference of two squares, it's this. Do y'all remember that now? Is it coming back? Yes, no, maybe so.
Yes, ma'am.
Okay, good. All right. Number 30, the difference of two squares. Number 31. Anybody have a guess as to what that is?
Is it D?
Close. Close. If it were D, it would look like this. But since you have that middle term, it's this one. We did that we did this in class when we did the difference of squares. We actually did a thing where when something is a perfect square, that you have a perfect square at the front, a perfect square at the back, and then when you multiply these two, which would be a negative 20x, you would double that. And it said 2ab. Does that ring a bell? If not, you could always slide and divide on that one, but those are big numbers. But this was a special factoring pattern for a perfect square. So what I would do if I were you guys when looking at these, Reese, you were very smart and astute to realize that the leading term was a perfect square and the ending term was a perfect square. So kudos and hats off to you. That was amazing. And you realized also that the first term, the square root of it was 4x, and the last term, the square root of it was a 5. So that was amazing that you picked that out. Be very proud of yourself. But when you have a middle term, all right, when you have a middle term and the first is a perfect square and the last is a perfect square, you want, more than likely, it is going to be a perfect square binomial, which means it's going to have an answer that's going to look like either A or C. So then you want to then narrow it down and look for the square root of the first and last term. Does that make sense to you guys?
Yes,
When
ma'am.
okay, when it's 3 terms. There will only be one like that on the exam, I think. All right, 32. What is that one? Reese, I know you've got this one.
Is it B?
Yes, good job. You go, girl. All right, number 33. 2 factors that multiply to give me a positive 32 that when I combine them give me a negative 12. Anybody have that one?
Is it C?
You're close. Positive 4 and negative 8 give me a negative 4.
Oh, so it's D.
Yes, good job. D. I think somebody else chimed in and said D also. So kudos to you. All right, number 34. 2 terms that would give me a negative 70 when I multiply them, but when I combine them would give me a negative 3. So the bigger factor is going to have to be negative. What is your answer for 34?
D.
D? Did I hear D?
Yes, ma'am.
Yes, that is it. Good job. Number 35, 2 terms that give me a positive 45 that when I combine them give me a negative 14. That means that to get a positive multiplication, I either have to have 2 negatives or 2 positives. And this negative right here tells me that it's going to be 2 negatives. So what is my answer?
D.
D. Good job. Number bigger of the 2 is going to be negative. What is my answer? Number 36. Two factors that multiply to give me negative 80, that when I combine them give me a negative 2.
Is it D?
D. You go, girl. Number 37. Two factors that multiply to give me a negative 5, that when I combine them give me a negative 4. One is going to be negative, one is going to be positive, and the bigger one is going to be negative because that sign in front of the 4 is negative. What is my answer?
Is it A?
Bigger one is going to be negative.
C?
C.
Oh, so C. Okay.
C. C. Good job. So you got the factors right, but you have to make sure that you're checking those signs. Is that making sense to everybody as we kind of review this factoring? Is this helping?
Yes, ma'am.
Okay, cool. Are y'all doing good on this page? Am I wasting time, or is this a good place to review?
I like this.
Okay. All right, good. All right. Ooh, number 38, slide and divide. And oh, how much fun we're going to have sliding and dividing on this. I'm going to need my calculator. It's 150 minus 3 is 147. I think 3 times 49 is 147. Has anybody done that?
Okay, well, we're now at the point of like where I need help. I've done everything before problem 38, but after 38, there's some scattered here and there that are confusing.
All right. This is a slide and divide. And I just multiplied the 3 times the 49 in my head by doing 3 times 50 and subtracting 3. And I got 147. And did anybody already work on this and slide and divide and know that Miss Sparks is right? Has anybody done this? Yeah, I did. I got it. Okay. So now I'm looking for two factors that multiply together that give me 147, that when I combine them give me 14. So I don't know factors of negative 147 right off the top of my head. But when I add the digits 1, 4, and 7 together, I get 12. So I know it's divisible by 3. So 3 goes into 14 4 times with 2 left over. That's 27. So that's 49. So let's see. 21 and 7. 21 minus 7 is 14. So X, and my bigger factor has to be 21 because this is a negative. So I slide and I multiplied by what? 3. So now I'm going to divide by 3 because it's slide and divide. And whatever you slid and multiplied by, you divide by. So X minus 7, because when you divide, if it's a perfect integer, you just write it down. 7 divided by 3 is not a perfect integer, so we bottoms up. So 3x plus 7. So where is that answer?
A.
A. Good job. All right. Number 39. So is this a good place to land for a few minutes? Or does somebody want me to skip over this? Slide. And when we slid, we multiplied by what? 7. Slide 7. So because we want to remember that, because later we're going to want to divide by 7. Slide, divide, bottoms up. if necessary. So 2 factors of negative 49 that when you combine them give you a negative 48. Well, that's a praise the Lord, because that one's pretty easy. That can only be 49 and 1. And the bigger has to be a negative, because that's a negative 48. What did we slide? When we slid, we multiplied by 7. So we divide by 7. So 49 divided by 7 is a perfect integer. So that's going to be v minus 7. 1 over 7 does not become a perfect integer, so we bottoms up. So where's that answer? 7v plus 1 and v minus 7.
B.
B, good job. All right, on number 40, we can factor a 2 out first. So we've got 2 times 2x squared plus 13x minus 24. Now we're going to slide and multiply c by 2. Now we're looking for 2 factors of negative 48. Reminding myself I multiplied by a 2. Negative 48 that when I combine them give me 13. And a positive 13. It's going to be 16 and 3. And the 16 is going to be bigger. Now I slid down and multiplied by 2. So now I'm going to divide by 2. So that's going to be x plus 8. And I should be writing my 2 all along here that I factored out originally, because I don't want to forget about that. And bottoms up here. So it's 2 times x plus 8 times 2x minus 3. And that is A. How's it going? Is this helping? Could you guys do it without me?
Yes, ma'am, it's helping.
This is helping.
Okay, good. Okay, great. All right, so 2x squared plus 19x plus 9. We're going to slide, and we're going to multiply by a 2. I always like to write that to remind myself, because I got to slide and divide. And I am guilty of forgetting that divide step unless I write that 2. For whatever reason, when I write whatever I multiply by, whether that's a 7, a 2, a 4, or whatever it is, it's really very helpful for me to be able to remember that. So now I'm looking for 2 factors that multiply together, give me a positive 18, that when I combine them, give me a positive 19. That's going to be x plus 18 and then x plus 1. Now remember, I got to divide by 2 because I multiplied by 2 when I slid. So that's x plus 9. And then this does not become a perfect integer, so bottoms up. 2x plus 1. So I'm looking for an answer that has 2x plus 1 and x plus 9. A. Number 42. 5x squared plus 32x plus 35. So I'm going to slide x squared plus 32x 175. So I'm looking for two factors that multiply together to give me 175 that when I combine them give me 32. Anybody already have those factors?
I don't.
Miss Sparks was 41C.
A.
Oh, A. Okay.
This
Yeah,
is like
they-
one of the things I don't want to have to do on the exam is a big factor tree.
Well, this one wasn't as bad as you would think as big as the 175 is. So we're done with that. And it's going to be 25 and 7 because that adds to be 32. Yeah, I know. Y'all, none of y'all are a very big fan. I forgot to write this down earlier. So we slid and multiplied by 5, and now we're dividing by 5. So that's going to be x plus 5. And this is not 7/5 is not a perfect integer, so we bottoms up. 5x plus 7.
Can you do 47? Or 43?
I can.
Just kidding.
43? Oh,
Yes, ma'am.
absolutely. Yes. Okay. Is everybody okay if I erase this right here? And if not, I will
Yes, ma'am.
rewrite it. Are we
done
okay?
like the whole packet except for 48, 49, 51, 53, 60, and 61.
Okay. All right. Well, good. Way to go. All right. Factor by grouping. When you're factoring by grouping, you're going to divide the 4-term polynomial into 2 sets of 2. And then you're going to look for the greatest common factor in the first set and in the second set. And you're going to hope that you get matching blobs. Do you remember matching blobs? That's the factor by grouping thing, is where the blob thing came in. So what is the greatest common factor of 7m cubed and negative 2m squared?
M squared.
Good job. You go, girl. So m squared. What would that leave me if I factor out an m squared out of 7m cubed?
7m minus 2.
Good job. All right. What is the greatest common factor out of 56m and a negative 16? Anybody know? It's 8. And you have matching blobs. So we have 7m squared times m squared plus 8, or vice versa. You could write it either way. Either one could go first, and our answer is actually written the other way. Nope, Miss Sparks circled the wrong one. I'm very sorry. Watch those signs. Can be tricky. And that was another thing I do, even though it's a multiple guess final, I do go back through. If you show your work on your test, I look for places to give you credit if you need it. So make sure you show your work. Like this didn't happen on the Algebra 3 final, which they've already taken because those are my seniors. But I have had in the past where students have taken a multiple choice test and they actually had the right answer written. And this has actually happened with you guys, where some of you actually have shown your work and written the right answer, but then wrote it. You know how there's an answer blank sometimes to the side on our tests, but you actually wrote the wrong answer in the answer blank.
Miss Sparks, can you scroll to number 42 for a second?
I erased how I broke this part down, though.
That's okay.
That was X.
That's okay.
Okay. I have it in the answer, but it looked like that.
Okay, thank you.
All right.
Okay, thank you.
Number 44. Looking for the greatest common factor out of 7x cubed plus 56x squared. Anybody have any guesses as to what the greatest common factor out of the first set of parentheses is?
7x squared.
Good job. 7x squared. So if I'm going to write it down here. I have more room. Seven x squared. So if I factor a 7x squared out of a 7x cubed, what's left?
X plus 8.
Good job. And what is the greatest common factor out of 4x plus 32?
Four.
Good job. And we would have x plus 8. Matching blobs. 7x cubed plus 4 times x plus 8. Confirm our answer is correct, and there it is. Okay. You want me to keep going with 45, 46, and 47?
I don't know about the other people, but
Man.
I don't.
Okay. Okay. All right. I can. I have some yays and I have some nays, but, and then Grayson, what's the next one you have a question with after these?
48, 49.
Okay. All right. All right. I'll do these and then we'll move to the next one. Oh, whoops. On this one, we have a greatest common factor, it looks like, to come out first. No, we don't. I lied. All right. So grouping, I'm going to divide these into two groups of 4, or 2 groups of 2. And what is the greatest common factor out of the first section?
A squared.
A squared is definitely it, but I also have a coefficient. These are some weird ones because this is not a number we think of frequently being able to divide out. But does anybody know what number will go into both 56 and 49 by chance?
Seven.
Yes. So we have a 7a squared. And then that will give us an 8a plus 7. And then out of this second set, we can take a 2. And that would leave us 8a plus 7. So we have matching blobs. Eight A plus 7. Greatest common factor that comes out of the first set of parentheses is 2x squared. And that's going to leave us 3x minus 4. The greatest common factor to come out of the second set of parentheses is a negative 7, which would leave us a 3x minus 4. Does everybody see how I got that?
The
Remember
grouping
when
is
you
my favorite thing that we've learned this whole semester, I think. It's pretty easy.
Oh, good. I'm glad that you're seeing that pattern. That's great. That's awesome. And thanks for sharing the parts that you like. That's good. That's good. So on that, remember the key to number 46 is making sure you get that subtraction sign in when you're grouping that second one, because you want to pull out that negative number so that you can get matching blobs. 2x squared minus 7 times 3x minus 4. Once again, on number 47, you want to make sure when you're grouping these terms that you get that negative next to that 20x. And so your greatest common factor in that first set of, or your that first grouping is going to be 7x squared. So that's going to be 4x minus 1. The greatest common factor that you can pull out of that second part is going to be a negative 5. Which is going to leave you 4x minus 1. Matching blobs, 7x squared minus 1, 4x minus 1.
Hey,
So
Miss
where
Rox.
is that? Yes.
Courtney's wondering
Minus
if
5.
you're needing to do 48 and 49.
What, honey?
Courtney's wondering if we need to do 48 and 49.
Yes, we're going to do them.
We need to do them?
Yes. Why?
Because Courtney just doesn't want to join math. I haven't asked herself.
Yes, we're going to do them. I'm just about to get there. All right. So I wrote it wrong the first time. It's 7x squared minus 5 and then 4x minus 1. So it's A. Is everybody understanding grouping, and did that help? Does anybody have any questions about grouping? Discriminant is just that little part under the radical of the quadratic equation. So remember, the quadratic equation is the opposite of b plus or minus the square root of b squared minus 4ac. So that means that little part under the radical is b squared minus 4ac. So the first thing that you need to do is get the equation in standard form. Is number 48 in standard form?
I'm gonna say yes, but I'm pretty sure no.
It's no. Standard form means that it's going to be set equal to 0. And there's a 10 over here. So you have to subtract that from both sides to get it to standard form. Does that make sense? It has to be in standard form. Subtract 10 from both sides. So now we have r squared plus 4r plus 4 equals 0. So now we identify A, B, and C. A is 1, B is 4, C is 4. Does everybody see why that would be really important? If I would have assumed that number 48 was in standard form, my C would have been incorrect because I would have said it was 14. What is C really after I get it in standard form? What is C? Anybody? It's written there. What is C? What is the value of C?
4.
4. Okay. So does everybody understand why it's so important to get it in standard form? You have to have the correct value for A, B, and C before you can do the answer. Does that make sense to everyone? And yes, I will give you this formula.
Yes, ma'am.
Hold on just 1 minute, guys. Sorry. Okay, sorry about that. My greyhound needed to be let out. All right, so now we're just going to plug in the values into the formula. So that's 4 squared minus 4 times 1 times 4. So 16 minus 4 times 1 is 4. Negative 4 times 1 is negative 4. Negative 4 times 4 is 16. 16 minus 16 is 0. So that means the answer is 2 real solutions. No,
How many
I lied.
of these
I lied.
problems are
It's not. Wait a minute. Hold on just 1 second. It's 1 real solution. My bad. If you get a positive result, it's 2 real solutions. If you get a 0, it's 1 real solution. And if you get a negative, it's 2 imaginary solutions. Or no solutions, but on here it'll be 2 imaginary. I'm sorry, what did you ask?
I was wondering how many of these weird problems are going to be on the exam.
I think one or two.
Okay.
So you're going to find the discriminant. So is number 49 in standard form?
No.
Good job. So I'm going to add 5 to both sides. And that's going to give me a 0, because if I add 5, that would cancel that out. So I've got negative 8 x, I've got negative x squared minus 8x plus 0 equals 0. So the A in this one is negative 1, the B is negative 8, and the C is 0. So B squared is negative 8 squared minus 4 times negative 1 times 0. So 64, negative 4 minus 4 minus negative 4 times a negative 1 is positive 4, and positive 4 times 0 is 0. So it's 64. And there's 2 real solutions. It's positive, so there's 2 real solutions. So if the answer is positive, 2 real solutions. If it's 0, 1 real solution. And if it's negative, it's 2 imaginary solutions. Solve each by factoring. Okay, looking for 2 factors that multiply together that give me a positive 25, that when I add them, give me a positive 10. So that's going to be x plus 5, x plus 5. So they're actually exactly alike. So I set them equal to 0. Answer is D. How are you all doing with these types of problems? Are you all doing okay? Should I skip towards something else?
I'm doing good.
51 and 53.
Okay. All right. 2 factors that multiply together that give me a negative 12, that when I combine them, give me a negative 1. That's going to be k minus 4, k plus 3 equals 0. Set each little tiny factor equal to 0. That's going to give me a positive 4 and a negative 3. Positive 4, negative 3. Number 52. 2 factors that multiply together to give me a negative 7. And when I combine them, give me a negative 6. Then take each little factor, set it equal to 0. And that would give you a positive 7 and a negative 1. Number 53, 2 factors that multiply together to give you a negative 42, that when you combine them, give you a -1. So that's going to be 6 and 8, or 6 and 7, sorry. I can't multiply apparently today. So that's going to be a -7, because the bigger of the two has to be negative, and a +6. Then you take each little factor and set it equal to 0 to solve. Subtract 6 from both sides and you get a -6. So the answer is 7 and -6.
Thank you.
Uh-huh. Number 54. You're going to divide both sides by 8 to begin with, because you want to get your x squared variable by itself. Or a squared in this case. So that's going to give me a squared equals 100. Take the square root of both sides, and that's going to leave me plus or minus 10. Number 55, 9k squared equals 9. Divide both sides by 9. That gives me k squared equals 1. Take the square root of both sides, and that's k equals plus or minus 1. And we did 56 the other day, and 57, 58, and 59 in the other math lab. I can go back over those, but I'd like to cover 60 and 61 to be sure I get those done. And I need I need to finish up in the next 5 to 10 minutes. So if I did not cover something in math lab today that you still have a question about, please bring your reviews to class tomorrow and ask me specific questions so I can address those in class. All right, sketch the graph of each function and identify the vertex and axis of symmetry. Well, the first thing I have to do, absolutely, before I can start, is find my vertex and axis of symmetry, or I can't even move on from here. So the axis of symmetry equation is the opposite of B over 2A. So I have to find my B and my 2 and my A. So A in this one is 1. My B is 4. So the opposite of 4 over 2 times 1. So X equals -2. So I'm looking for something that goes down -2. Then I want my vertex. To find the vertex, I plug in my X back into my equation to find my Y. So that's -2, please use parentheses, plus 4 times -2 plus 6. So 4 minus 8 plus 6. So -4. Hold on just 1 minute. All right. Sorry about that, guys. The Greyhound's acting crazy. -4 plus 6. So that's a +2. So my vertex is -2, 2. So I'm looking for a vertex at -2, 2. So that means A has a vertex at -2, 2. B has a vertex at -2, 2. C does not. D does. So the next thing I'm going to do is I know that it has to be a happy face. So I can eliminate B, and I've already eliminated C. So now I've got it narrowed down to, no, I don't, because D is a frowny face too. So the only one it could be is A. If you had to further narrow it down, you would want to then do your table of values to try and narrow it more. Okay? So my axis of symmetry is x equals -2, and my vertex is -2, 2.
Could you remind me of why it's a smiley face instead of the other one?
Absolutely. The leading coefficient, whatever is on the x squared term, if it's positive, it's a smiley face. If it's negative, it's a frowny face. Because if you're positive, you're usually smiling. And if you're negative, you're usually frowning. So it's that leading coefficient on the x squared term. Does that make sense? So knowing that information, number 61, is it going to be a happy face or a frowny face?
Frowny face.
Frowny face, because the leading coefficient on the x term is negative. So you could automatically eliminate letter A right off the bat. Okay? Does that make sense? So now let's point out what A is, -1, and B is -6. And the axis of symmetry formula is the opposite of B over 2A. So the opposite of B over 2 times A. 6 over -2. So x equals -3. So my vertex is x equals -3. We've already eliminated A. And we can actually eliminate C and D, really, at this point. But I've asked you in the directions to identify vertex and axis of symmetry. But does everybody understand why we could eliminate C and D?
Yes, ma'am.
Okay, because the axis of symmetry for C is x equals -1. The axis of symmetry for D is x equals 3. But let's continue to find the vertex so we can complete the problem, although we do know that the graph is going to be B. But to complete the problem for the vertex, we have to plug in that value of -3 into the original equation. Please, please, please exercise caution when plugging in. I have to put that minus because that's literally saying I've got a -1 times -3 squared. Does everybody understand why Miss Sparks just did what she did? So I've got the opposite of -3 squared, which is 9. Then -6 minus 3 is a +18 minus 12. So -9 plus 18. This seemed to be where y'all got tripped up most of the time on your quiz, your take-home quiz. So my vertex is -3, -3. The other thing you could have done to find that point is to look there on the graph and identify it as -3 for your vertex. If you got your graph narrowed down, you could do that instead of doing the math. But this is another way to confirm what your answer is.
Thank you.
Uh-huh. Okay, guys, make sure you bring these reviews to class tomorrow. If you need me to rework any of them or you have any other questions on one of the other pages, please let me know, okay? You will have for your formula sheet at the very end or on exam day, the discriminant formula, the quadratic formula, and the vertex, or the axis of symmetry formula, the -b/2a. I will give you those on exam day. They will either be written on the board or you'll have them on a scrap sheet of paper.
And this packet counts as the quiz grade, right?
I don't know whether I'm going to make it a quiz grade or a daily grade or what I'm going to do yet.
Please do a quiz grade, please, please. I'm confident in my answers. I need the good quiz grade.
Yeah,
You said a quiz.
yeah, I know, but here's my struggle with that. What I've noticed is, like I even said, the assignment sheet would be a quote unquote quiz grade, but that would have tanked a lot of people because a lot of people are not showing their work and you're going to get 0 credit for not showing your work. So I don't really want to give somebody a 0 for not showing work, and I've already given most of the answers out. So what's going to end up happening is a lot of people's going to search, because it's multiple guess, people are going to just circle answers, and then they're going to end up with a quiz grade of a 0. And I'm trying to benefit those. My whole goal was to benefit people, not to hurt people. So I don't really know what to do with people who aren't showing their work, even though I've asked for the entire school year to please show work, even when it's multiple choice.
Okay,
But
so
a lot of
here's
people
a
are
suggestion.
just,
The homework packet can be a daily grade, and this exam packet can be a quiz grade, but they
Oh,
don't
I
get a
should
grade if they don't show their work.
yeah, well, I've been saying that all year long and people continue to not show their work. So I don't really know what to do. I hate to give you a 0 at the end of the school year.
Can you
You
scroll
know
to
what?
56 right quick, Ms. Parks?
I absolutely can. You want me to redo it, buddy?
I'm just checking to see if I got it right.
Okay. I'm trying to take all 50 of my students in Algebra I into consideration when I figure out what these grades are. And I was actually, it's very disappointing the number of people that still aren't showing their work at the end of the school year. So, I mean, I have some of you who are absolutely are knocking it out of the park. So, you know, what I tried to do is make sure that you all are getting credit for that. And for those of you who are actually showing up to Math Lab, either both times or a minimum of 1 time a week, I'm trying to make sure that somewhere in your grades it's reflecting that. For those people who are going the extra mile, I absolutely try to make your grades reflect that for participation or whatever. But so Grayson, you're good about showing your, almost everybody who comes to Math Lab, it's kind of interesting. The consistency of people who show their work, come to Math Lab, are usually y'all's grades reflect that you come to Math Lab, show your work. So Grayson, you don't really need, oh, he left. I was going to say he doesn't even need the extra bonus points, but I try very, very hard to give you guys credit for showing your work and or showing up to math lab. But usually anybody who shows up to math lab are usually the ones that are showing their work. So, but I also don't want to completely hurt somebody at the end of the school year for not showing work. I'm just trying to figure out as a teacher what I need to do better about emphasizing showing your work at the beginning of the year. But are there any questions, more questions about the math packet? It's definitely going in as a grade, and it's definitely going to be 5 bonus points on the exam.
I've had a question on 57, 58, and 59. But you could do that in class.
Okay. And I also did them in math lab the other day too, at the very beginning of math lab, I think. But you know what? I'm happy to do them again in class tomorrow. That's where I'll start. Okay, Courtney? Will you remind me in class? Do you mind reminding me, even if you write me a note and put it on my desk?
Yes.
That's absolutely where I'll start. Okay?
Thank
in
you.
your class. Not a problem.
I had a question about number 13.
13?
Yes, ma'am.
Yes. I think all of the work is at the top. Do you see it? I broke it down. I broke it down where I did the bottom first, because 3 times 0 is 0. So m to the 0 power, you can see where I crossed it off and made it a 1. And then I combined my n to the 9th and my n to the negative 3rd, and then that became a 6. And when everything leaves the top, you have to put a 1 and negative 2. So the negative 2 comes to the bottom, and 3 minus 6 is negative 3. So it stays in the bottom. Does that make sense?
Yes, ma'am.
Are you, I'm sorry?
Yes.
Okay, cool. But
Miss
please
Sparks?
bring your math. Yes?
Could you do number 59 at school tomorrow?
Absolutely. I will do those. That's what Courtney was asking me, I think, and you're in her class, right?
Yes,
I'm
ma'am.
going to I will start with 57. I did do them in math lab the other day. So if you have another question over the weekend or whatever, 57, 58, and 59 are on Tuesday's math lab. And I believe, if I'm not mistaken, they're pretty close to the very beginning.
Okay.
Okay.
Thank
So
you.
if class tomorrow doesn't answer the question, then you can absolutely go back and watch the recorded math lab from Tuesday. And this one will be recorded and posted as well. Okay?
Thank you.
All right.
Thank you.
No problem. Don't forget to bring your math packets to class tomorrow, these exam packets to class tomorrow for credit for a grade, and also 5 bonus points on the final exam. Okay?
Thank you.
And thank you for coming to math lab. Bye. Love y'all.
Hey, Miss Sparks.